Select the statement that best describes the reaction below at equilibrium. So what we're trying to say is, what will we have a greater concentration of? Will we have a greater concentration of the reactants once this solution reaches equilibrium? Or will we have a greater concentration of the products? And so since this is an acid-base reaction, we need to find the side of the equilibrium that has the weaker acid and the weaker base. And we will say that is the side of the equilibrium that is favored. So we say it favors the weaker acid and the weaker base. So we don't have pKa values given to us, which means this is a problem we can solve by applying our cardio trend. So our cardio stands for roughly the order of importance of the structural features that we consider when we're trying to determine which is the weaker acid or the stronger acid. So C is charge, A is atom, R resonance, DI dipole induction, and O stands for orbital. And this also comes down to hybridization. If we want to know what type of orbital something is, then we need to know the hybridization of that atom. And so we can see by examining the reaction that the ethyne is donating a proton to this anion. We see it's lost a proton. So that means that this is an acid, right? So this is an acid, this is its conjugate base. If this is a base, this is its conjugate acid. So we know that we're comparing the ethyne and the propane as our acids. We could have also figured that out by the charge. The negative charge tends to indicate a base. Okay, so if we're comparing ethyne and propane in terms of charge, well, they're both neutral. In terms of atom, well, that would be the atom that you have a hydrogen attached to, right? So you'd be looking for the most acidic hydrogen. Well, in ethyne, you only have hydrogens attached to carbon. In propane, you have hydrogens attached to carbon. Resonance. So that's once you form an anion, can you draw any resonance structures? We cannot for either of these. Dipole induction might be the presence of an electronegative atom somewhere. None of this is getting us to what we need to know. So it comes down to orbital and hybridization. So now we need to consider the hybridization of the carbon atoms. So this is the carbon atom of ethyne that we have taken a hydrogen from, and you might recognize that this is perfectly symmetrical, so I could have indicated the other carbon as well. So we need to know that this carbon atom is sp hybridized. And then with the propane, we want to recognize that the carbon atoms of the propane are sp3 hybridized. And so this is really the example that we see orbital. It ends up being really, really important for these hydrocarbons because this ethyne, we will find out, is actually a lot more acidic than you would think. So the general trend for orbital, and it's going to apply to hydrocarbons. So you're going to be looking at alkynes, alkenes, and alkanes. So here is the trend. It is that sp hybridized carbon atoms are more acidic than sp2, which are more acidic than sp3. So this is the most acidic and the least acidic. And we can actually look up the approximate pKa values. So the pKa of an alkyne is approximately 25, and of an alkane is approximately 60. That's a huge number. This is a really, really, really weak acid. So we would say that ethyne is the stronger acid, and propane is the weaker acid. So with this information, we could say that this equilibrium is going to favor the products because it's going to favor where you form the weaker acid and the weaker base. And we could label our bases as well. We should hopefully be starting to recognize that the stronger the acid, the weaker its conjugate base. So that your weaker acid and weaker base are always on the same side of the equilibrium. It's physically impossible for it to be any other way. So we don't actually need to label all of those. Okay, so it's going to favor the weaker acid. So we just got to find out which one of these statements describes it. So it's definitely going to favor the products, And ethine is a stronger acid than propane. That's the accurate statement there. Okay. And you might wonder why. So why is ethine so much more acidic? It has to do with this orbital. So your sp orbital is 50% s and 50% p. And your s orbitals are smaller and closer to the nucleus. And the nucleus is where all your protons are. That's where you have a positive charge. So you're able to stabilize a negative charge by putting it next to the positively charged nucleus.